Concurrent processing has the potential to improve the scalability of software systems. The potential scalability is not realized unless the concurrent steps do not have to wait for other processing to complete. This is the idea behind unbalanced processing. This anti-pattern has three main manifestations, the first being concurrent processing systems, the second is the pipe and filter architectures, and the third is extensive processing. The problems that comes with unbalanced processing will be talked about in regards to the three manifestations mentioned before. For concurrent processing systems, problems occur when these systems cannot make effective use of the available processors. Then, unbalanced processing systems occurs either because of dedicated processors or single-threaded code. For pipe and filter architectures, the throughput of the overall system is determined by the slowest filter, which can become a problem. And finally, for extensive processing, the problem occurs when a long running time monopolizes a processor. The processor is then removed from the available processor pool, and work does not have to pass through this stage before proceeding anymore. This is particularly problematic if the extensive processing is on the processing path that is executed for the most frequent workload.
We're now going to look at three solutions to the problem introduced by unbalanced processing. The first solution is concurrent processing. If there is a large amount of single-threaded processing, multi-threaded processing should be used instead. When the problem is caused by having a processor assigned to a specific task, system execution models can be used to quantify the net effect of the processor assignment. The second solution is to implement pipe and filter-based architectures. This solution can be thought of in two ways. If there are short tasks that have high overhead due to context switching, these tasks should be combined into longer tasks so that context switching and overhead can be minimized. If there's long tasks, these should be subdivided into smaller processing stages. The third solution is to deal with extensive processing. This is done by identifying slowdowns and delegating processes such that they do not impede the fast path. The solution works best when there are unnecessary processing steps that can be offloaded to another thread.
So in conclusion, unbalanced processing occurs when a system is unable to efficiently utilize all of its available processors. The problem manifests itself in three typical scenarios. The first scenario is the pipe and filter architectures. The second of which is the extensive processing, and third would be concurrent processing. To these scenarios, there are three solutions or options of solutions. One is enabling concurrent execution. The second is fragmenting large filters into many steps and merging smaller filters into one step in order to reduce their overhead. The third scenario or solution would be to reallocate large processing steps to other parts of the system in order to minimize their effect on throughput and not act as a bottleneck on the total throughput of the system.